Hello everybody. Today I will talk about the grid operator API and how to connect the grid operator API to the grid singularity exchange. So the grid operator API is designed for grid operators, distribution system operators, and transmission system operators, and with the goal of to actively manage grid congestion by assigning new grid fees at each market slot for different markets at different levels of the grid. So as for the asset API, there are two main ways to connect the grid operator API to the grid singularity exchange. One option is through a local simulation, so by running a simulation in the backend on your own computer, or through a web running application from our user interface, the grid singularity map. And in this video, we will focus on the first option. So we will running a simulation together in the backend and connect the API to it. So first thing that we need to do is to initiate the server. And grid singularity we use Redis, so we will just have to go to our terminal window and type Redis server and press enter, and now as we can see we are ready to accept connections. Then we will have to define the community that we want to simulate, and as for the asset API I will use the same template script that we propose in our GitHub repository. It's called defaultcommunity.py, and a few different areas and houses have been set up in this script with different type of assets. We have loads, we have batteries, we have PVs. And what actually is of interest for us in this case is the market. So we have the grid market, we have the community market, and then each house consists of its own market below. But what we will do, we will want to connect to the grid and to the community market and apply the fees at this stage. So now I go to PyCharm, and we want to initiate the simulation by writing the command line, and we will start by writing GSYE, defining the log level as info, run, and then the tick length is about 5 seconds. The slot length is 15 minutes. We need to define and specify what is the setup file we want to launch, and this time is in API setup.default community. And we also need to communicate in this command line that we want to, of course, connect with APIs. As a consequence, this next flag is necessary: enable external connection. Also, after initiating the simulation, we want to have some time to launch the APIs and pause the simulation automatically. So the paused flag is also needed here. And finally, slot length real time equal to 10. This means that the 15 minutes of slot length actually correspond to 10 seconds in reality to be able to run the simulation a little bit faster. We can press enter, and in a few seconds we will see a message saying the simulation has been paused, and now by pressing P we can resume the simulation. We will do that in a second, but now let's look at the API, at the script that we will use as a grid operator API. So in grid singularity we propose many template scripts, and the one I want to talk about today and we will use today is called Redis TOU strategy.py. So TOU stands for time of use, is the grid fee strategy that I'm gonna implement in the example of today, and it consists of applying a different grid fee at any market slot every 15 minutes and a different fee, of course, if desired, for each market. So to maybe give a better idea, we can have a look at the file that the user has to upload, which is a CSV file, as we can see here, at any time, every 15 minutes, and for each market. In this case, as I said, we want to connect to the community and to the grid markets. A different value in cents per kilowatt hour is set. So going back to the script, let's have a quick look of how the script is structured. Initially, we want to list the names of the markets we want to connect to. In this case, as I said, grid and community. And then looking at the events in the script, in the on market cycle event, which is triggered at the beginning of each market slot, we set the new somehow grid fee, which is the grid fee which is associated to the next market slot in time, and we will print some interesting information in the terminal that we will have a look at just in a minute while after launching the simulation. So a little bit at the bottom of the script, the read fee strategy functions loads the CSV file we just looked at and returns a dictionary containing the same information. And then through the set new market fee, we loop through this dictionary and we retrieve at any market slot the new fee for the next market slot in order to be applied in real time. So we can also go back to PyCharm here and now write the command line for the API. So I will start by writing GSY SDK. I will set the log level also here as info. I will need to define the setup as Redis POU strategy. I need an extra flag here that communicates the fact that we want to run the simulation locally and we are not connecting to the user interface. This is run on Redis flag, exactly. And then the path, the location where the script is. In my case, I will quickly just write down my location. And we can press enter and we see that we are connected successfully with the two markets, grid and community, and we have a little summary here of the identifiers associated with the two markets. Now we can go back to the exchange side, press P, and let the simulation start. Simulation is now resumed. We can see all the trades on the exchange side. And what is more interesting for us now is to see essentially the prints that I was referring to earlier on the API side. So it is actually very simple. At every market slot, for example, here at the midnight 15 market slot, we just have a pretty simple summary of what is the current fee for each market. For example, it's 4 cents per kilowatt hour in both the grid and community market, and which is something that we have predefined initially. And then those are the values that have been taken from the CSV file, which are in this case 1.84 cents per kilowatt hour and 0.46 cents per kilowatt hour. And we can see that going through the simulation, those two values are of course the current fee of the next market slot, and new values are coming. So we can really easily keep track of what's going on and what are the fees that are applied to each market for every mark as load. And in order to conclude the video, I would like just to go back to our public wiki for a second and underline the fact that if you want to know more, and you can of course always consult our wiki, and specifically in this case in the grid operator API section here, there is a really detailed explanation and description of how the script has been coded, and the events and the commands of the grid operator API.